Okay. Now we solve for these two guys. Okay. Now we move on to the next joint. Okay, to try to figure out the other three forces. The question is, which joint should you go to? Now I've done joint A. Right? The next joint should be either joint B or joint C. Okay, because I've solved for these two forces. And these two members are attached to either joint B or joint C, right? So, and with these two being known, so that should help me in the analysis, okay, to try to find out the rest of the unknowns. Keep in mind, a joint should have no more than two unknowns, okay, two unknown forces. So let's say for joint B. Joint B have three forces acting on it, one of them being a known quantity now, so two unknown, so that's fine, that's good. Joint C has four forces, two being known quantity, so that leaves us two unknowns, so that's fine too. So either way, in this case, it's up to you. Joint B or joint C, it's all the same. Okay? Whatever joint you go for, you get the same result. Okay? Now, before we go on, however, though, in this very, very simple example, AC is 1 meter. CD is also 1 meter. This is 30 degrees, so this is also 30 degrees. It means that this truss is symmetrical. This means that everything is mirror image. Okay? With BC being in the middle. So AB has the exact same loading as BD. Now, since we found out that AB is 100 Newton compression, this means that BD right away is also 100 Newton compression. Okay? Exactly the same. You don't have to actually calculate it because it's mirror image. That's it. Same thing. AC is the same as CD. It's under 86.6 Newton tension. Okay? So that's the beauty of this truss analysis. If that's symmetrical, you only have to calculate 1/2 of it. Right? The other half is just simply a mirror image. So now, the only thing left to calculate is BC, okay, or FBC. So, like I said earlier, you can choose this joint C or joint B, okay, for your calculation. It doesn't matter, okay. So let's say I'm going to use joint C. Okay. So, draw a separate free body diagram. Okay. Joint C. So you always start with a big dot, okay, to represent a joint. Label the joint. Okay, joint C, and then draw all the forces acting on this joint. So now I have this 100 Newton, okay, this load, and I have three other forces. So 1, 2, and 3. I'm going to call this FAC, this is FBC, this is FBD. Okay, now notice that I haven't drawn arrowheads just yet, right? But can you figure out the directions once again, just like before? Yes, using Newton's third law, no problem. But this is even the easier way here. Look at this up here. Since we've already figured out FAC pointing to the right out of this joint A. Now this is also FAC, but this is from joint C point of view now. Okay? So all you have to do is just flip the direction of this guy right there. So that's your direction of FAC from joint C point of view. Okay? So it's actually pointing to the left at the count of this guy. These two are equal but opposite. Okay? Once again, Newton's third law. Right? So this is how you can borrow what you just calculated earlier from the other joint, right, into this new joint. Okay? So this goes to the right, so this goes to the left, although they're the same force. Okay? And from earlier, we calculated the FAC is 86.6 Newton. So you do know that. Okay, so now you look at these two unknowns. Looking at this picture right there, everything is horizontal or vertical. So right away, okay, from all the exercise you've done, right, from solving all the problems, you should see right away that this FCD naturally has to go to the right. FBC naturally has to go up. That's all. That's the only way. Okay? To be in equilibrium. So, knowing that these two forces, right, are pointing these directions, so now this free body diagram is complete. So now you can apply the equation. X equals 0 and some forces y equals 0. Now it's very simple. Everything is x to y direction. There's no slanted force, so there's no decomposition, right? So actually right now, okay, some of you might be able to see that right away, okay, the answers for these two, right? It's very, very straightforward. But let's go to the math, okay? Some forces equal x equals 0. So only these two guys in the x direction. So therefore, FCD minus FAC equals 0. Here, FCD is the unknown, so move FAC to the right-hand side. FAC had been solved for earlier, so that's it. So FCD is 86.6 Newton, which is this right here. Okay? So we've just proven that, okay, this is actually true. It's actually symmetrical. What about this guy right here? Fy. Okay, so only these two guys in the y direction, so FBC minus L equals 0. So FBC equals L. L is 100 newtons. Therefore, FBC is 100 newtons. There we have it. However, is it compression or tension? This FBC pointing upward, away from the joint, does that represent a compression or tension force? Use the same method. Newton's third law. Okay? If you can't still visualize in your head, draw it out. Draw the actual member. Draw member BC. Right? Draw. Let me just erase this guy right there. I don't need that anymore. Okay. So draw this member BC. Okay. This is joint C. This is C, as it belongs to this member right here. Okay. Newton's third law says for every action there has to be an equal but opposite reaction. Okay, so this, they'll call it negative FBC. Okay, so third law, okay, gives you this result. Knowing that this points down on the other side of this member, you have to have equal but opposite also again. Now look at this picture now. Tension. Therefore, this 100 is 100 T. That's it. This is the final presentation of the result.